All right, welcome to The Explainer. Today we're jumping right into a classic clinical puzzle, jaundice. But forget just memorizing a bunch of facts. We're going to tackle this like a medical Viva, building the logic from the ground up so you can solve the case of the yellow patient every single time. Let's get into it.
So here's the deal. A patient comes in, their skin is yellow. The first, and honestly the most important question you need to ask is this one. Is the problem before the liver, in the liver, or after the liver? Think of it like a factory. Is the issue with the raw materials, the factory itself, or the shipping department? Every single clue we look at today will point us to one of those three locations. Okay, but before we can play detective and figure out what went wrong, we've got to know what right looks like, right? So first, let's take a quick tour of the body's bilirubin processing factory when it's running perfectly, with no glitches at all.
Picture this beautiful, efficient assembly line. It all starts with old red blood cells breaking down. Their waste product is this raw, kind of toxic stuff called unconjugated bilirubin. It can't just float around freely, so it hitches a ride on a protein taxi called albumin, which takes it straight to the liver. The liver is our amazing processing plant. It takes that raw bilirubin and conjugates it. Basically, it just makes it water-soluble so we can get rid of it. From there, it's shipped out into the gut with bile where bacteria work on it, and eventually it becomes what gives stool its normal brown color. It's a perfect system. Now, burn this flow into your brain, because every type of jaundice is simply a breakdown somewhere along this exact path. So when a patient turns yellow, it means that elegant pathway has failed. Our investigation immediately narrows down to 3 prime suspects, each corresponding to where that breakdown happened, before, in, or after the liver. And this right here, this is our evidence board. This table holds every single clue we need to crack the case. For the rest of this explainer, we are going to go full-on medical examiner on this thing. We're going to dissect this chart box by box, not just learning what the findings are, but really hammering home why they are that way. This is the core of our entire investigation. Let's start with the first row of evidence on our board, the blood work. What type of bilirubin is backing up in the patient's system? This is our first major clue to locating the problem. So let's actually think it through together. Based on that assembly line we just talked about, what kind of bilirubin would you logically expect to find if the problem is before the liver? What about in the liver or after it? The logic is absolutely everything here.
Okay, suspect number 1, hemolytic jaundice. This is a pre-hepatic problem. So imagine our factory, the liver, is working just fine. But all of a sudden, way too much raw material is getting delivered. The workers are fine, but they're just completely overwhelmed by the sheer volume. So what happens? You get a massive pileup of the unprocessed, raw, unconjugated bilirubin right at the factory doors, which is the bloodstream.
Now, what if the factory itself is sick? That's hepatocellular jaundice. The workers are struggling, the machinery is busted, so they can't process the raw material efficiently, which means unconjugated bilirubin starts to rise. At the same time, the shipping department is also a mess, so some of the finished, conjugated product that they did manage to make ends up leaking back out into the blood. You see why it's a mixed picture? You get a failure at multiple steps.
And our third suspect, obstructive jaundice. This is a post-hepatic problem. Here, the factory is working perfectly. It's taking in the raw material and processing it beautifully into the finished conjugated product. But the exit door is blocked. A gallstone, a tumor, something is in the way. That finished product has nowhere to go, so it just backs up and spills right into the blood. Okay, we've interrogated the blood work. Now, let's move on to the next line of evidence. We're going to look for clues in the most obvious place, the output. What can the patient's urine and stool tell our investigation? Because believe me, they tell us a lot. Now, the absolute key to understanding urine color in jaundice comes down to one single crucial property. You have to know this. Only conjugated bilirubin is water-soluble. That's the secret. And this makes it crystal clear that raw, unconjugated bilirubin is fat-soluble, and it's stuck to that big albumin protein. It's way too big and bulky to get filtered by the kidneys. It just can't happen. But once the liver does its job and makes it conjugated, boom. It becomes water-soluble, it's free, and it can easily pass through the kidneys and into the urine. This single concept explains everything. So if we apply that logic, the clues just fall into place. In hemolytic jaundice, all that excess bilirubin is unconjugated, so it can't get into the urine. The urine color? Totally normal. In both hepatocellular and obstructive jaundice, that water-soluble, conjugated bilirubin is backing up into the blood,
where the kidneys filter it out, turning the urine dark. And with a really bad blockage, you get a massive amount spilling over, making the urine very, very dark. Okay, now for stool. The logic here is even more direct. The brown color of stool comes from stercobilin, which is made from bilirubin down in the gut. So it's simple. If bilirubin can't get into the gut, then you can't make stercobilin, and the stool can't be brown, period.
So let's run through our suspects again. In hemolysis, there's more bilirubin getting into the gut, so you get more stercobilin, making the stool darker. With a sick liver, bioflow can be spotty, so the color is variable. But in obstructive jaundice, if there's a complete blockage, 0 bilirubin reaches the intestine. No bilirubin, no stercobilin, no brown color. The stool becomes pale, chalky, clay-colored. We call it acolic stool, and it's a massive, massive clue.
All right, we've analyzed the blood, the urine, and the stool. It's time for our final and often the most decisive piece of evidence on the board. This one can be the real clincher. Let's talk about urobilinogen.
So just remember the pathway. Urobilinogen is made from bilirubin by gut bacteria. A little bit of it gets reabsorbed into the blood and then shows up in the urine. So let's think this through. How would the amount of bilirubin reaching the gut affect the amount of urobilinogen we find in the urine?
The logic is just a direct chain reaction. It's like dominoes. More bilirubin in the gut means the bacteria make more urobilinogen. More urobilinogen production means more gets reabsorbed back into the blood. And more in the blood means more gets filtered by the kidneys into the urine. It's a straight line.
And this chart just lays it all out. In hemolysis, you're flooding the gut with bilirubin, so urinary urobilinogen is high. Makes perfect sense. But in obstruction, no bilirubin is reaching the gut, so no urobilinogen can possibly be made. It's completely absent from the urine. That is a huge finding. And the sick liver and hepatocellular jaundice? Well, just like stool color, it's unpredictable, so the result is variable. But that presence or absence of urobilinogen, it's an incredibly powerful clue.
So we've done it. We have filled in every single box in our evidence table with solid step-by-step reasoning. But why does this matter so much? Why go through all this trouble? Because getting the location right, before, in, or after the liver, is not some academic exercise. It dictates crucial, sometimes life-or-death, clinical decisions.
I mean, just look at the difference here. If all your clues point to hemolytic jaundice, you're dealing with a medical blood disorder. Your next step is a hematology workup. But if the clues point to obstructive jaundice, you are potentially facing a surgical emergency. Your next step isn't more blood tests. It's getting urgent imaging to find and possibly remove that blockage.
And that's really the bottom line. Correctly interpreting these signs is what separates a medical problem from a surgical one. And if you get it wrong, you could be managing a patient with supportive care when they desperately need an operation. The stakes are just incredibly high.
So we've walked through the entire logical pathway. The challenge now goes to you. Could you take that blank evidence table from the beginning and fill it in, not just with the answers, but with the why behind each and every one? When you can do that, that's when you know you've truly mastered it. Thanks for joining me on The Explainer.